In this video, we will be talking about heat and work. More specifically, we will go over on what is heat and work, their similarities and differences, how they are related, the different modes of heat transference, and look at a particular type of work we use in thermodynamics. As we will approach the end of the video, I will talk a little bit about what is specific heat capacity and how it is related to what we discussed. So, what is work in thermodynamics? In short, work requires force and displacement. As we can see here, in this illustration here, work is represented as the integral of force times displacement. But if we look at it in a thermodynamics point of view, I find the best way to demonstrate what is work is suppose that we have this box filled with moving gas particles, which we will consider to be our system. So right here in image 1. So to do work, we say that this system does work if it exerts macroscopic forces on its surroundings. Now, here's what I mean. Let's add a free moving piston. So this illustration here. The gas particles will be moving around and colliding with each other. When these particles hit the moving piston, it will result in a macroscopic force exerted on the piston. So the microscopic force ends up pushing the piston away. So as you can see here, we can see in this illustration here how it's pushing the piston upwards. So this is why we can say that our system is doing work on its surroundings, which in this case, it's clearly doing work on a moving piston. This particular type of work can be split into two, compressive and expansive. As we can see in this illustration, the two types are shown. The compression, which creates a negative work, and expansion, which creates a positive work. So we say that compression gives a negative work because we need some external force pushing down on a moving piston. Whereas when we have expansion, it's a positive work because it's creating the gas particles are creating are pushing away the piston, which is creating work for us. Now moving on to heat. In short, heat is a change in temperature. By intuition, we would think that heat and temperature are the same thing. In fact, they are closely related, but they are not the same thing. Temperature is a measurement of thermal energy, whereas heat can be defined as a transfer of energy from or to a system. In other words, we could also say that temperature is a way of describing how hot or cold an object is, and it can be measured in Celsius or any other unit of temperature such as Fahrenheit. And heat is a form of energy that can be measured in joules. So as you can see here, heat, we have a change of temperature from high to low. And for temperature, we see that we have for high temperature, we have fast particles, and for low temperature, we have slow particles. It's just a measurement. So how are heat and temperature related? Well, it's simple. The more heat you transfer to a system, the more its temperature will rise. Now, another thing to note is that there are different modes of heat transfer. The first one being conduction, which is energy that is being transferred between the physical touch of two objects. So we can see here the saucepan's lever is transferring heat onto the person's hand. The next one is convection, which is energy that is being transferred by the movement of a fluid. In this case, the movement of water, so we can see how it's going from hot to cold. The last one, being radiation, is the energy transferred without any physical touch between objects. So as you can see here, the radiation of fire, if you were to put your hand without touching the fire from a distance, you would feel it's a heat transferring onto your hand. There are other radiations, such as a lamp or a sun. They all produce radiation. Moving on to a few similarities and differences between heat and work. So for similarities, we can say that both heat and work are ways of transferring energy from one system to another. They are both measured in joules. They are both path functions. What I mean by path function is is that if you want to go from state A to state B, there are different paths you can take. And depending what you want, some paths are more advantageous than other paths. You know, when it comes to work, you might want to minimize your work, which means you want to take the path that has the less area. Some differences is that heat is a form of energy, whereas work is the amount of energy being transferred. Heat is thermal energy, whereas work is mechanical energy transfer. And finally, work requires force and displacement in a macroscopic level, and heat requires a change in temperature. Finally, another important element in heat is heat capacity. In short, heat capacity is just the necessary energy that is required to raise the temperature of an object by 1 degree Celsius. Specific heat capacity is similar to heat capacity, but the difference is that now you want to raise 1 kilogram of substance by 1 degree Celsius. The formula for specific heat capacity can be described as follows in this picture here. Q is the heat that is being absorbed or released in joules. M is the mass. C is the specific heat capacity of a certain material. And delta T is the change in temperature in Celsius. So, believe it or not, we use specific heat in our everyday lives. The best example would be when we are cooking. The material you use, such as a frying pan, all have a specific heat capacity. So having a small specific heat capacity would be very useful, since when we apply heat to it, it will heat up a lot faster and therefore boil the water much quicker. So, in thermodynamics, this is an important element to understand because we are interested in energy, and this tells us how much energy is required to heat or cool an object. That will be all for this video. Thank you for listening.